Hello everybody, thank you for joining us today and welcome for today's webinar. Today we will focus on new version StatiCa 8.2, and before we start you can put questions during the whole session to the question window, and we will answer it after the practical part of the webinar. Today, my name is Marek Michna. I am sales consultant in StatiCa, and today I have here Jana and Vít, who will guide you through the practical part. Version 8.2 is the third during this year, and it's almost 3 years when we introduced our unique solution for design and check of all steel connections according to the codes, and since then over 1,000 companies around the world significantly improved their connection workflow. And this release is special in terms that we implemented requests, mainly requests from you, from all customers around the world. So this is the product which is mostly done with your cooperation. And okay, let's start with the practical part. The first thing is related to the beam links, and I will give a presenter to Vítek. And we start with this beam improvements. Okay, let me.
Thank you, Marek.
Okay.
Hello to all attendees. Thank you very much that you join us today. We will start with the practical part of our webinar. We spend a lot of resources to improve the beam links. This year, we created new finite element analysis links, for example, Stat Pro, RStab, Revit, Advanced Design, ETABS, and so on. But the major improvement was in update function. Now we can use update function to reload or re-import changes in a cross-section or in load effects without losing any other data that we inputted, for example, manufacturing operations. This we will show you in a first practical example in a few minutes. Also, we spend a lot of time with improving the C8 links for Tekla and advanced steel. We have no problems with importing bended plates. We improved rounding, so we can input fine, smooth plates for better modeling. And we improve intersections and welding of hollow sections, of circular hollow sections, square hollow sections, and so on. New things were improved, like detection of the welds and contacts between entities which are not bolted together. Really important feature, we prepared for you a new way how to import the loads. In past versions we had, and we have it now too, possibility to import load effects from previously prepared Excel spreadsheet. Now we can import loads from a project that we did before or we imported. And this allows us to, for example, create an import from finite element analysis tool, and we get the load effects. And if we import from another tool, for example from Tekla or Advanced Steel, when we import from CAD program, we get the manufacturing operations. Now we can close the circle, and with the import load function, we can import the load effects from the first model and calculate everything. We don't need to input any other data manually, so we can use two import functions and calculate. We prepared for you first example, which is the link between SCIA Engineer and IDEA StatiCa connection. We have this really nice structure, steel structure, and we want to import this joint. I have to notice that the project had to be calculated, and we have results. If we have results, here is the here will be available the command button for IDEA StatiCa connection with two commands. Let's input the joint. Our joint will be number 1, for example, 1, and we will choose this joint. It's here, and it contains all members which are connected. Now we will choose only check, and IDEA StatiCa connection window will automatically appear in a few seconds. I have it on the another screen, so here it is, and we have our import. As you are used to, we have all necessary data in geometry, cross sections, angles, offsets. We have our load effects from all combinations, and we have to design it. To speed up the process, I created the template in advance, and I will apply it. I will choose the bolts. Now it's done. And you can see I have to correct only the length of the member M27. Now it's great. Now we prepared our joint, and you can calculate it. Now we will save this joint, close it, and of course we want to change something a little bit. For example, we can change this beam, its cross section, to another one. We will choose this pipe. Now you can see we have changed the cross section. We let calculation begin, and once we will have a result, we will go to steel and again check our joint. The re-import of the cross sections, geometry data, and of course the load effects is performed, and now you can see here we have a different cross section, and the manufacturing operation which was defined is applied, and it's okay. We don't need to do anything else. We have our joint designed, and we can immediately perform the check. And that's it. That's the update of the project. let's say we have a manufacturing model, for example, imported from Tekla Structures or from Advanced Steel, and it looks like this. It's without the load effects. We have only the all manufacturing operations. And we have import from finite element analysis tool, which can look like this. Just give me a second. It can look like this. It's without any manufacturing operation, but with all load effects, with all combinations imported. And of course, we can use the new feature. Let's go to the load effects, import the loads. We will find our project. And the all load effects is imported. So now we combined two beam links with one another feature, and we don't need to input any other data manually. This is the end of the first example, and we will continue with the presentation. Another thing that we spend a lot of time on it is the project documentation. A lot of users asked us about possibility to import or export to the gallery or to the DXF or to the JPEG the pictures in the data window, for example, the results on the plates. Now you can simply click on it with a right button and import it whenever you want and use it. Other thing is that in version 8.0 we give you information about the formulas and values which are used for the code check. Then next step is to use these formulas in the report in version 8.9. We will show you this in a second live. Our report was redesigned, and now we have only one item in the navigator, which is preview and print, and we have here we have all items which can be modified by drag and drop function. And here at the bottom of the window, we have simplified tools for choosing and modifying your desired report. Which leads us to the next practical example. Just give me a second, I will open the project file. Here it is. We have here several items, and we will go to preview and print, which is our new report. Great. Our report is prepared. Now you can see we have here project data, paragraph, materials, etc. And I want to have the paragraph at the top and the project data at the bottom. And yes, I want to have the software info here. Next thing is that I want to have these views, and for example, formulas are shown already, and for example, bill of material. Now the paragraph function. What is it? We prepared for you a new feature. Here in the project data, we have a special tool which we will use. And I prepared in advance some nice text with for example, some picture or photos. It's really up to user what he wants to use, what he wants to show in the report, and only by function copy and paste, I will paste it here. And if I use the styles for the headings in Windows Word, we can restyle it to our styles and use it with same styles like in document. So now we have prepared our document with user text, user input, our new styles, which are really nice, clean, without any problems, without any info more. Here are the values and formulas in report, and basically that's it. Next, we will continue with our presentation. It's about CBFEM components, and that is the part of Jana. I will ask her to take the presenter and continue with our webinar.
Okay. Thank you, Vitek, for the nice presentation. And in my part of this webinar, we will have a look at some new features of the CBFEM components first. So according to many requests we have received from our users, we are still trying to improve the software and implement the useful things that really you can use in your everyday practice. And the first one is, for example, the new type of, or new types of welds, sorry. And so now you can use, beside the standard continuous weld, also only the partial weld with defined offsets on both ends, and also the intermittent welds, which is separated into shorter parts and with gaps in between. I will show you an example how to define such weld after the first part of this presentation. The bolts have been also improved, and now you can use also the slotted holes of bolts. And with this feature, you can really play with the shear force transfer in your connection. So, for example, this figure shows you that you can define two groups of bolts, and the top group is defined with slotted holes in the vertical direction, which means that these bolts will not carry the shear force. I will also show you how to define slotted holes in an example. And I want to mention also that you can decide which bolt will be with slotted hole and which one will be with regular hole. So it's really, you don't have to define it for the whole group, but only for single bolts that you want. We have also added new types of contacts. In the previous version, there was not possible to define the contact between edge to edge, which is possible now, and I will also show you. And also, you can define a contact between edge and surface. So, for example, the right connection, it's kind of bizarre connection with only the top flange welded to the column, and the rest there is a defined contact between the edge of the beam and the surface of the column. So you can see that it also is possible to be modeled in IDEA StatiCa, although it's not really used in practice. In the new version, you can find and improve anchors. Now they are also acting in compression. So it is possible to define, for example, such anchoring with a gap between the concrete base and the steel base plate of the column. You can see it in this example. Or you can define also some mortar layer under the steel base plate. And now it's time for the first practical example. So let me just change the screen now. Okay. So I hope you can see it. To be fast, I will not define all the manufacturing operation from scratch, but I have prepared them before, and I will only turn them on, and I will speak a little bit about them. So to connect the horizontal beam to the column, I have chosen to use the end plate, and you can see that I have the slotted holes here implemented. It can be done in editor. If you open the editor and bolts, you can see that the shape of the hole can be changed here, and also, for example, the ratio of the shape can be defined. So I want all holes to be slotted in this vertical direction, and this means that the bolts will not carry the shear force, the vertical force. So I have to add some member that will carry the shear force, and I have decided I will weld such piece of steel under the beam, and now I have to define the contact that will act in compression. So it's possible with the operation general weld on contact. You can see the placement is edge to edge and type contact, and in the display, in the transparent view, you can see it as a red line here. This is a defined contact. Okay, now I will switch all the welds around the steel plate. If I turn to solid view, I can see it again. And one more thing I want to add, because in the end plate, I have turned off the welds on the web here, because I want to show you the partial welding. So I will add a new operation. The operation is general weld on contact. And you can see that I can choose between continuous type, the partial weld with offsets, up and down, top and bottom, or intermittent welds where I can define, for example, the length or the gap between. Okay, so, and I think I'm done with the design, and I can proceed to the calculation. You can see probably I will not present all the results because this webinar is based on new features of IDEA StatiCa. So I think it was presented already, and I will continue with the presentation of some new manufacturing operations we have added. So with the new version of IDEA StatiCa, you can design really very general anchoring of your columns. For example, such an example of heavy anchor of any beam or mast, very stiff. And with the new general anchoring, you can even create such crazy anchors. It looks like something from sci-fi movie, but this should be only an example that it is possible to anchor or to use more concrete blocks in one joint, and they also can be in either direction. So you can use the vertical anchoring and also the horizontal anchoring in one connection. And it's not displayed here, but it's also possible to anchor more members into one block. So this is also possible. As I mentioned before, you can also model the gap between the base plate and concrete. Now you can also use ties or rods for your bracings. It's in the connecting plate and gusset plate operations, and they can be welded to another steel plate. For you who use splices a lot, probably you found the definition of splices quite long in the last version. So there's a really good news for you, because now you can define the splice in one operation for both sides of the splice. So you don't have to separate the group of bolts on one beam and the group of bolts on another beam. Now it's in one operation, and you can also add the backing plate on the other side of the splice in this operation. So I think this saves a lot of your time. New features for cleats are, for example, they can be used also on an inclined beams, and also if you have the same beam on the opposite side of the column and you want to use the same connection, now it's also easier. You don't have to copy the operation, but it's in one operation, and it places the same cleat on the opposite beam. So the same can be used also for splices. It can be automatically copied on the opposite beam in one operation. Stiffeners, of course, we had stiffening plates in the last version, the general ones, and now it's much faster to define, for example, the internal stiffener of hollow sections or such a cap plate. So we have also made this operation faster, and we have added a new type of cuts, especially for tubes. It's a miter cut, and now so you can cut the tubes with the miter cut in one operation, and they can be also welded together. And with the new contact edge on edge, it's also possible to weld edge on edge, so you can connect two members with the same cross section, as you can see those two H columns on the right side of the slide. It's also possible to be done now. And with the welds, it's really improved that you can use the weld around the hollow square hollow sections and weld the same sections together, which are perpendicular. So, for example, beam and column of the same sections can be welded now also very easily. Okay, and I think that's all from my side. Maybe we have time for any questions. I will pass the presenter back to Marek.
Thank you, Jana. I already have presenter and also Vítě. So now it's time for your questions. Before this part, just let me tell you that after the webinar, you can fill short form where you can put also the question about what else you want to have in IdeaStatiCa, what new features, what new functions. So you can put this answer here. And if you are interested in a trial license, you can also put this information in this form. And again, we are recording this webinar, so in 3 days you receive email with link to YouTube, and you can check again this webinar. Also, just quickly, I show you on our website the page where you can already see a lot of webinars which was done, and so you can check it. So now let's see on your questions. I have here the first question. Can you show us how to define this new type of general anchoring? Maybe Vita, you can take this question.
I will better show it.
Sorry.
Because I have one example here.
I will give you presenter back. Yeah.
Okay, thank you. Okay, I hope you can see it now. It's also a project we show to present the new general anchoring. So the operations are here. I will only turn them off. So to define the general anchors, from my example, I had to define a stiffening plate, the general one, which will be the base plate, and I have welded the column, and then you can add different stiffening members, of course, weld it together. And now I will add the anchors, and the anchors are added as a general group of bolts, and you can see that now you can choose between bolts, anchors, and contact. And if you choose the anchors, all the foundation block is created here. Okay, so I have 2 anchors, and in the second grid I will choose another 2 anchors, and these anchors will be anchored into existing block, not the new block, but the existing block. So you can see that you can really define an anchor or one block and make more anchors into this block. And then the last 4 operations are only the stiffeners. So you can see that in the more general operations, you can define such quite difficult anchoring system. But of course, for the easy anchor or blocks, you can use only the one operation, the base plate operation. It's still there, so you don't have to define everything manually. For example, such foundations are modeled, or such anchor is modeled in one operation. Yeah, and here, for example, I can show also that I can choose different shear force transfer. So if it's transferred by friction, shear iron, or anchors, and also I can choose the standoff. So I have presented it in during the presentation. It can be direct or with the mortar layer. I have to define some thickness of the mortar layer. Okay, you can see it here now. Or there can be a gap, for example. So all this is done in one operation.
Okay, thank you, Jana. Let's have a look on second question. It's related to the welds. Is it possible to input more welds on one edge? Vita, maybe now.
Yes, it is. I will show you in a practice. Just let me turn on the connections. We will start from scratch. It will be just a second. So here we are. Let's define a new connection, only the basic type, for example, the T-joint. And we can design a end plate, only simple one. And I will give here 10 millimeters to be more realistic. And I will turn off the weld on the flanges, and I will show you how to define separated welds on a rolled cross section. For example, if you want to place two welds, to be sure that in the part where is radius there is no weld. So I will choose the manufacturing operation weld, and here I will input the plate of member B bottom flange. Now here it is. We have already our weld, but it's the continuous one and we don't want it. So here is the new combo box in which we will choose another option, which is partial, and this will allow us to input the offsets from one side. This will create this kind of weld. I will input here, for example, 5 millimeter weld, and if I will copy it and do the partial from other side, now I have two welds, each one at one side of the flange, and I created it like in a real cross section. Here in the part where is the radius from the rolling, there is nothing. So this can allow you to be more accurate, but it's up to you if you choose to do it manually and to be more efficient, but it will cost you some time. Okay, Marek, do we have another question?
Thank you, Vitya. Yeah, we have another question related to the weld connection. Can you show us how to define connection between two tubes using this new feature?
Okay. I will create a new one. Okay. For example, this one. We will pick up some hollow section. For example, some pipe. This one, I like this one, and member B2 will be this with the same cross section. Okay, that's the necessity to have the same cross sections, and I will pitch it a little bit. For example, 45 degrees to have it like this. If you are familiar with the designing the connections, you will understand that this was the pain to design such kind of connection. Now it can be done only by cut, and we will cut it by miter cut. It's a new option here in cutting method, which allows you to connect these hollow sections, and it creates an intersection of two members. It's calculated here, and it creates a really nice connection with weld in every segment, which is correct for the connection. Okay, another question?
Okay, thank you, Vitya. And there was question, is it necessary to have the same names in the CAD and FEM model to combine the manufacturing and load information?
No, it's not. We control the topology, and you can have a little bit different topology. For example, if the angle is 45 and in other is 46, degrees, the load effects will be imported. But it's up to you how you design your analysis model and your structural model. It's up to your engineering feeling if it's okay to compare different models. So it's up to user. We will do it, but the final decision is up to you.
Okay, thank you, Vitya. And okay, that was the last question for this moment. If you have any other questions, please send it maybe by email, and we will answer it ASAP. And
we will also answer those questions that we are not able to answer right now, but we can see them and we will write you an email.
okay, thank you. And so thank you for your time, and we are looking forward for the next webinar. Thank you, and goodbye.
Goodbye.
Bye.